So we open a new file and then we name it, we save it to some location. You'll have something like this. I will do it very quickly so we can make use of the time in the design. So you have to design your grid, okay, this beam grid where you want to draw. This is an isometric view. You can change it to whether you want like a plan view in the XY direction. You can see it from the top, you can see it from the bottom, from the side, wherever you want. Okay, let's assume I want to draw a floor. Then I will go to the top view and I have to edit this grid. The grid is now is shown in XY. I want to see it in the XZ plane. From the top, it will be the XZ plane, and you can divide the spacing as you wish. So if you want to see this one as edit slab and this one, okay, grid linear, and this is X1 view. Okay, this is the 3D view, and we are seeing now the plane of XZ. This is X direction, and this is the Z direction. The default divisions is 1 to 10, 1 to 10, 1 meter, and you can change it at any time. So if you want to edit this one, you go there, and if you want to increase the number of digits here or number of divisions, you can increase it 15, for example, up to whatever you want. You can change it like this, and this one you can change it also as this one. Then you start drawing at this location. Okay, if you snap node beam, you see the cursor is now active. You can draw, for example, your beam. First beam is 5 meters here at this location. Okay, second beam is another 5 meters. Third beam is more there, and so on. This one. Okay, I finish these beams, then I can copy all these beams. I can do translation and repeat for this one in the Z direction, for example. I want to do a 4 steps, and each one is 4 meters, and link steps with this one. So it will generate for me now the whole floor. I can remove some of these beams if are not there, whatever this one. So this is the beams, the floors, interesting. I can form now another floor if you want, or I can model the foundation, the columns downward. If I want to model it in the Y direction, second floor, I will do translational repeat in the Y direction. Okay, number of steps 2, and the default is 3.5, the height of the story again. Link steps, yes, link steps, and this will generate for me the building. Then if I want to add the columns here, I can add the columns for the foundation, or I can select the nodes at that location. Then I can do like side view. You need to learn this one yourself, and there are videos. I can use the cursor here just to select all these nodes, not the beams. I always view it in the 3D. See, I am selecting only the nodes. I go to the geometry, then I say translation and repeat in the Y direction, and I want to one step down, just the foundation or the columns is 3 meters below. I give it negative because opposite to the Y direction downward. Link steps, yes, it will generate for me only like support columns. Okay, I can generate the supports, for example, or the supports are, I can create pin support, fixed support, whatever this one. Let's see pin support added. Then I can also view it in this direction. I can select all these supports as a 3D, all supported. Then I will say assign to the selected beam. Assign. Yes. Okay. Then I go to the loading and whatever you want until you formulate the loads for each floor, live load, dead load. For example, just I'll show very quickly that I want to add, for example, the properties, the section properties. For example, I will add here, define a section properties, rectangular section, the beams in the x direction, I will assume it as zero point 0.5 depth and with 0.2 as meter width. And then I will say add, and I will define in the uh, z direction zero point 0.4 by 0.2, and then add, and I will assign the columns to be like 0.3 by 0.3, for example, square columns, add. Then I have to go there and assign this one to the extension. So I have to select all the beams. We go to the select here and we select parallel to the for example, parallel to beams, parallel to the x direction. So it will select for me all the beams parallel to x, and I want to assign this one to the selected beams. Assign. Yes. Then I go to the second one, and I say same thing, parallel to the z direction now. It will select all these, assign. And then I go to the third one for the columns. I say parallel to the y direction. This is parallel to the y direction, assign. You see, I assigned the section with the material, concrete material, so I don't need to go to the materials there because it's already assigned. So I have now modeled this one. Then I can go to the loading. Loading, I can add loads. Load number one, case number one, it is a dead load. I have to define it as a dead load, add. Load number two, it is a live load. I will call it live add. And then I go to define combinations. Combinations, I have an ultimate combination 1.2 times the dead load and 1.6 times the live load. You see 1.2 case 1, which is dead load, 1.6 case 2, which is add. So I formulated all these loads. Then I go back and add what are the items inside this load. You have different items. You have nodal loads, member loads, area load, floor load, and so on. If you want to apply a load on the floor, then we go to the floor load. Okay. Then I have to define it according in your case, you have to define it as a range. For example, you have to specify the pressure. The pressure is for coming from the dead load, like 8 kilonewton per meter square, for example. Where you want to add it to which floor, for all floors, then I keep this one the same, and I don't specify. It will apply everything here in this one to the all floors, and it will act or apply them as a two-way slabs. If you want to specify one-way slab, then you have to specify that here, one-way slab, and in what direction you have to say that this is one-way slab. Just for simplicity and for, I will add it like a load pressure all over the loads. Then I'll go to load case number 2, which is also a live load. Live load, I will add it also as a floor load, which is equal to -2, for example, kilonewton per meter square. Also apply it everywhere. In this case, I don't need to assign because already, you see, all they are divided as a two-way slabs, trapezoidal and triangle. Okay, because I did not specify one. If I want some of these, I have to specify that it's one-way distribution, and it is applied only on the first floor. Okay, this is first floor. If you want to edit it, you apply it all floors. You remember the distances in this direction. I think it was, we can go to the select, and we see the node selection, this one, to see the height, y is equal to 7 meters. So in this case, I can go to there, edit, and I'll change the Y from 0 to 7.1, just a little bit above this one, modify, then it will be applied everywhere. And then this one, edit, same thing, apply it to the 7.1. So any floor within this range, the load will be applied on that one. In your case, the loads maybe are different from different floors, so you have to specify each one alone, or even the areas. Some of these they have according to the strep method or to the distribution method. Then you have, in this case, different than the other case. Then you have to specify it as a range. What I mean by the range here, you have to specify the X range and the Z range. Then it will be applied at that location. Okay, combination is already assigned, and that's it. Material analysis and design. So if I want to analyze it now, I have to go to analyze. Then I have to add this command. Very important to add this command. Perform analysis. Perform analysis. Add is added there. Then we are ready to run the analysis. I hope we don't have any errors. It seems there is no errors. Okay, this is it. Then we can go to the post processing. We can see now the results, displacement. This is the displacement. Displacement is very small scale. I can change it from the scale here. The scale, you go to the displacement and reduce it. It will show you the displacement with, see, this is the displacement, apply. If I want to see, not the displacement, the moment, this is the moment. In this case, I have to also change the scale of the moment, M bending Z, reduce it. Okay. These are the moments. In this case, there's one point you should be aware that I have moments here at the edge of the beams. So, and I have moments in the columns. If I don't want the columns to carry moments only axial, then I have to release the end of the columns, and we can do this one using the. I have to go to the analytical model. I have to go to the specification. This specification, there is a beam specification where we have start and end. I release the moment mz. So if I add it, okay, and then I beam again. At the end, I release the moment mz and add. Okay, then I can go, for example, this beam, the green, you see the color, the green is the start and the blue is the end of the member. I need to release it at this end, at this start and at this end for this continuous beam, for example. So I go there, then I go assign, by use case to assign and toggle this specification. If you want to remove it, you can. So if I press there, then an internal hinge will start at this location. I can do the same for all these beams that coming in this direction. Just I am releasing the top just to save time, and I can release these ends there like this. Okay, ends, this one here, this one at this location,